Hello everyone, I'm Mr. McBrien. This is TJ3M, Turing 6, Working with Files. Yesterday we talked about random numbers and remainders, and we talked about some applications of these ideas. Now, a lot of these big mathematical problems, we don't want to work with them independently inside our application and then just stop. We'll tend to want to interact with the outside world, whether it's through Excel or other kinds of ways of inputting information, for example. So today we're going to talk about, first off, loading and displaying pictures, something that can be a lot of fun for various applications. And then we're going to talk about loading data, simple text-based data. And this will cover a large part of the way we want to interact with other applications, particularly once we talk about the ability to write out the results of our program such that we can take it into other applications as well. Notice as well, too, that writing out as extra files will enable us to use the same application on different days and have it remember the results of a given session. More on that later, though. Okay, so let's talk for a second about memory. So far, every program we've written so far, every application we've written so far, has used its own code exclusively. And anytime we wanted to put information in, the user had to type that information. And this creates a ton of limitations to the kind of workflows we want to do. Really, most programs of any importance need some kind of additional information to work appropriately. So if you had a crossword maker, it'd need a word list. If you had some kind of photo editor software, it would need to be able to import pictures. And if you had some kind of modeling tool, it would need to be able to output the results of its model to be able to be visualized in Excel, for example. Most information flows will involve additional files of some sort or another. Okay, so let's go through some of these piecemeal. As far as pictures go, I think you can appreciate maybe this piece as easily as anything. You can enhance the appearance of your applications by simply just importing pictures. And we can use GIFs and JPEGs, and we can use other more rudimentary pictures as well, like bitmaps. And we can display those inside our applications. Now, the only real questions there are the location of the picture, which we'll get that in the next slide, and some overlay options which are worth thinking about for a few minutes. So you can do things like overlay pictures on top of what was underneath. You can do things like move the picture underneath other objects that you've already placed on the screen, or combinations of these things. So this is useful to think about because, of course, any of you who have worked with PowerPoint in any detail know that the location of the objects and the way different objects interact is important. So if you decide your project involves pictures, you'll be using these functions in some detail. I've left them here just to think about. And remember that these are called the mode. All right. Really, I'm more concerned with just making sure we know how to display the images. So the commands are as shown here. We need to, as usual, declare the variable. And we need to import or load the picture to memory before we display it on the screen. And so these are the commands here. If your mode is irrelevant, you can just use a 0 for it. There is one more thing to think about when you're using pictures. When you load the picture, it's loaded into RAM. Until you free up that picture, until you use the pick free command, you are using up RAM. And so if you're done with that picture, you can go ahead and scrub it from the RAM. Keep in mind, that does not mean you're clearing the screen. It just means that you're moving the picture out of RAM. So for full marks on any programs you have that use that command, you will want to essentially use the pick free command after you've used the picture for the last time. Okay, so a quick activity. What I'd like you to do is build an electronic photo album. So put some pictures into a folder. I don't care what they are as long as they're not inappropriate. And create a slideshow application that essentially moves through the folder by displaying the pictures one at a time using a delay. And I would like you to note in your application comments any restrictions that you put on the situation. Any things that you assumed that made the coding easier. And at the same time, after you've noted these things, you could talk about some of the things you would need Turing to be able to do to remove these restrictions. These may exist, they may not. I'm not asking you to research these at this point. But noting restrictions you've placed on your application is a very good habit to get into as you write code. Okay, so go ahead and code up that photo album software. It should only take you a few minutes to create that loop, and then come back and we'll talk further about additional software memory. All right, welcome back. Let's talk about libraries for a minute. Sometimes applications require large amounts of information, and this information may not be contained in the compiled software in Windows. And you can hard code this information into your software, for example, declaring a series of thousands of variables. And we can even talk about easier ways to achieve those things later. But the question is, what happens when the information in your software needs to be updated? If you have a list of all of the cars, for example, that are for sale this year, and two manufacturers come up with new cars, well, then you have to recompile your software to be able to display those things. And so this isn't really great. You don't want to recompile your software for a few simple data files. Rather, what you want to be able to do is access external data files that contain what you need and simply reference those inside your application and load them as you need them. And this will enable you to have a much more versatile piece of software. So things like lists can be updated very easily by simply referencing a folder. You don't want to compile them into your program unless you're pretty sure they're fairly permanent, or if you're worried about somebody hacking them for some reason. And there are some ways you can get around those pieces as well. Okay, so a similar situation where you want to look at files is generating output files. We can send our results to the screen, and we've done this many times inside our software already, but it's not a very permanent result. What if we want to keep the results from our program for some additional task? For example, logging sensor results, taking calculations out for Excel analysis, creating written reports, many other possibilities, even just saving the results of our session to be opened in a subsequent session. So as our applications become bigger and more elaborate, the output and retaining that output becomes more and more important. So really, pulling information from a file is not significantly different than accepting it from the user's input. We have to open a connection to the file. We have to send something to a file through a file number variable. We have to retrieve it using a get command. If we're retrieving a list, a very important thing can be figure out if you've reached the end of the list. And we can close the connection to a file in order to allow it to be available for other applications by using a close command. So there's a very few simple commands that we can use. Now let's illustrate these in a bit more detail. So we open a connection to the file in order to access it. And again, we need to be able to declare a variable before we start. So we can open, in this case, open our file that's data.txt, and then we can get a given value from this. And this opens the connection. Getting the value, we can simply create a simple .txt file, place it in your Turing directory. You don't have to, of course. You could specify the full path if we wanted to. What I'd like you to do is put a series of numbers in the file. For example, 10 numbers in your file. And I'd like you to write a Turing application to open the file, read the first number, and write it to the screen. And it should look something like this. But go ahead and do that yourself and make sure that you can do this effectively. Okay, and that's kind of interesting, but a single value isn't that exciting. It's much more interesting once we get to lots of words or numbers, lists. So we can trigger the get command as many times as we want, and Turing will keep track of which strings are done as it goes. You can separate given words or given numbers by spaces or by carriage return. It's important for us to keep in mind the end of file command. So Turing will move through the file accessing the data, but it won't stop unless we tell it to stop. So what we need to do is, in our loop that says to get the value, get our number from the list, we need to have an exit command. So exit when end of file. And if we put this inside our loop, then we can loop our program, and here's activity 3, taking our get command and putting it into a loop that ends effectively once it needs to. So this is what I'd like you to do. Simply duplicate my code effectively for your own system and spend a bit of time debugging it as you need to, and access a given list of things. So you can design an interesting workflow around this or not. That's totally up to you. But make yourself a loop that reads each number from your text file and outputs it to the screen. So go ahead and do that now and pause the movie while you complete it. Okay, welcome back. Next, we want to be able to write our output to a file. And once again, we have to open a connection to the file in order to access it. So we'll do the same thing, declare a variable, open our process, our connection, and then we use the put command, putting it inside a file instead of putting it onto the screen. Pretty straightforward. And of course, doing this once isn't very exciting, but doing it many times gets a bit more powerful. So activity 4 is to create a compiler. What I'd like you to do is write an application to allow the user to enter a series of names and automatically place them into a TXT file. And this application should stop when the user enters the text done, so you'll need to be sure to incorporate a check in there. So go ahead and do that part. Alright, so to summarize, many pieces of software need to be able to have memory. We can't store new information inside compiled code. When the application shuts down, it loses the results of our session. We can use libraries to keep our code small and to allow our software to access information only when it's needed. And updating data files is faster and easier than recompiling, debugging our code every time we make a small change to some information. And using output files means that we can learn from what our software does. Each session can result in some learning for our system. Thanks very much. Have a great day.